great. So again, Wayne Davis, an SA solutions architect out of the East Coast. Let me ask a quick question. How many of you have experience, exposure with our machine learning platform? Okay, all right. So we got a nice little mix. So all of you will be tasked with helping those that do not. So we'll keep that in mind. Now, what about this? How much have you done with the AI platform that we offer? Much? Anyone has hands-on experience? A little bit here or there? Okay. All right, perfect. All right, so we've got a nice little workshop that's to follow after this. It'll be challenging, it'll be fun. We'll figure things out. It's not actually my lab, so we'll figure it out together because I haven't run through it as well. So again, right, the team that was supposed to come this morning, they had a family emergency. So thank you for being flexible, patient, and willing to adapt on the fly. If you think about this right here, this is an interesting statement that you'll find out that data with reference to how we use it is the new oil. What do you think that means? Yes, sir. It's valuable. Okay, what about another analogy? Someone mentioned valuable. What else?
It's a resource that you can keep drilling into and producing something out of it, so gas, kerosene.
Okay, gotcha. An infinite supply of something. Yes, sir.
It's misused in the world.
Oh, okay. I like that. What else? Yes.
Somebody wants to pretend it's a scarce commodity.
Oh, okay.
It's a fuel that drives the world.
Ah, the fuel that drives the world. And maybe one more. America's going to go after it? Oh. Well, I understand we got a pretty good supply up in the mountains in like Alaska and all those other areas. But as all of you stated, right, data is extremely valuable, especially with reference to how we quantify it and we quantitatively use that data to get something as an output. In the case of what we're talking about today, machine learning. So it's nice that we can drill into these techniques and look at all the different things, but it's also electricity. Now, why do we say this? Interesting.
It has come to revolutionize many aspects of our world,
Okay.
like electricity has done in the previous century.
Okay, so we use it across the globe. All right, what else, sir? All right. Should be instantaneous, always there. And maybe one more. Totally what? Yeah. Okay, all right. So value, data to action, all important things. Now, if you look at the screen right here, you'll see that we have several different offerings right here. With regard to artificial intelligence, we love to use this term, but we use it loosely, but also we need to be very specific and prescriptive on what it actually means. So early on in history, right, from the early 1900s, we've used this term. We've had it available. We've used it in our everyday environment. Prior to Amazon, I worked in the Bay Area as well, down at a small little networking company called Cisco. We used a lot of that to do some of our analytics as well. So AI is just ingrained in everything we do. But most of us in the public, generally speaking, we typically don't use it. So what are some of the different types of machine learning? Well, let's take a look here. If I were to ask you to describe supervised learning, what would you say? Yes.
Level training data.
So what kind of training data?
Level.
Okay, level training data. What else? Yes, sir.
Where someone, an environment where someone will interact, and depending on what the interaction was, they get feedback
Yep.
as to what they should do next.
Okay, all right, yes. Pre-classified training, okay. So if it's pre-classified, it's already structured, then what is unsupervised? Yeah, okay. Gotcha. So binary, I heard something over here. Autonomous. Would you say chaotic? Yeah, so data really doesn't have to have any legs. It just is a mechanism for us to pull it together and use it. So in machine learning, you'll see that there are tons of different classifiers, classifications, techniques, learning, descriptors, there's linear regression. You have deep learning, which is a whole other ballgame. We have computer vision that we'll talk about. These are all mechanisms that are important to the machine learning mantra that's out there, but more importantly to the different iterations that you'll end up using to have recommendation engines and our platform to be successful. Now, going through a lot of the stuff right here, how many of you have an Alexa at home? Okay, all righty. That's good. That means the vast majority of you must have something from Google. Interesting. Okay, well, we are in the Bay Area. So ideally, if we can take that data and quantify it, pull it together, use it, then it's a wonderful thing. In my environment at home, I use my Alexas to program my lights, to turn on my systems. I've got some things hardwired into my fridge. It's cool tech that all of us can use, irregardless of the platform that you choose to have in your home. Now, one of our primary goals here, if you look at our mission statement, is to make sure that when we put this in the hands of all of you, whether you're a data scientist, and by the way, everybody is a data scientist today, or also a developer, it's important for you to understand that that data is at your disposal and it's important for you to determine how you use it. So we have several techniques that we have employed here. If you look at our machine learning stack, this is not conclusive of everything, but more importantly, it is a small glimpse into the world of Amazon with regard to how we operate. Now, if you recall, one of the most important things that Amazon is predicated and bound to do is we like to sip on our own champagne, right? So when you see these services, we are already using them. We make sure that we build based on those services. And then these two gentlemen on my left and myself, we actually are the ones that are writing the development guides, the best practices guides, and the configuration guides that you see online. That's a hard requirement for the company, for us to work here. Now, it's nice because if you look at all of these different things here, if I'm working on vision, if I have speech, if I want to do anything with natural language processing, we probably have a tool for you to use. So I love down there in that middle layer because you'll see that all the different machine learning techniques, while 2 years ago we were using machine learning as its infancy, but then we progressed over the last 24 months with the SageMaker, and then later this afternoon, Forecast, and some other services that we'll dive into. But in the bottom layer there, just look there, you'll see that if you have a very specific niche, a need, we probably have an instance that you can support. We also have the GPUs that you probably won't even need, but they'll be available. If you need 100 GPUs, we got it. So a lot of different mechanisms to help you get your data crunched, processed, modeled, built, and then deployed. Now, what about our strategy here with regard to what we do moving forward? Well, you'll find that if we want machines to think, we need to teach them to see. I thought that was an interesting quote. And any graduates from Stanford in the room? Okay, all right. So you probably can relate to this, the two that are in the room, with regard to how important statements like these are. They're instrumental, they're foundational to our success. Now, what do we use? Have you used Amazon Rekognition before? All right, so what's been your experience thus far?
Well, there was a workshop here that we used to do some identification.
Gotcha.
Also, on my own, looking for vehicle identification.
Okay,
For surveying.
excellent. So, gentleman went to, what was the first name, sir? Bill. So Mr. Bill went to a workshop, used some identification with vehicles, so had a pretty good experience, you would say? Very basic, okay. Well, let me back you up just a quick story. In my environment back home, I work with a large manufacturer. They do a lot of the building for us. And it's pretty interesting because we've been using Rekognition to identify and relate how many parks and also how many parking spaces are in a parking lot at a given time that don't have cars actually sitting in them. So you can imagine, right, with Rekognition, it's pretty difficult to do because you've got to worry about, actually, let me ask you all, what do you have to worry about when you're trying to do something like that? Lighting, that's one. What else? Say that one more time, sir. False positives, yes. Had 1 million of those. What else? Okay, damages on vehicles, Mr. Bill says. Yes. What else? Yep. So the frequency of the data sets is also important. What about color? What about size? What about variation in depth, dimensions? Those are all important. So imagine you've got a blue truck, you have a white truck, you have a green truck, you have a car, you have a motorcycle, you have a moped. All those are different variations. Now, the only way that you can get that to be successful is if you have a massive amount of what? Right, training data. So data, again, has volumes. Now, if we come to the different recognitions, you'll notice that, right, we've got our leadership in there. You'll also find that we need to detect, but if you move to the furthest of the screen here to the right, what also is important?
Text and image.
Yeah. Do I want to add any data inside of the actual image? So a perfect example, if I'm doing a cat dog, and right, would I want to paint that on the screen that a cat is a dog is a cat? No, I want the dog to say dog, maybe pop it in the bottom of the screen. I can create a nice boundary box around it to make sure that I see all those data points. Yes?
What is unsafe image?
Oh, any idea? Any idea? Unsafe image detection.
Over 18 and under 18.
Ooh. Did you hear that? Over 18, under 18 is one descriptor. What else? Correct. So you could be at a military post. What about images that should not be displayed in the public? That's another classifier. Anything else? Unsafe image detection. What do you think? Right. What if I have sensitive data, right? My personal, my PII, PCI data, right? Do you want your hospital information with regard to your HIPAA to be seen, visible, to be captured on an image? Another example, I walk into a hospital, or no, we'll say I walk into my doctor's office, and should I be allowed to capture my picture and post it somewhere without my permission? No, that's illegal. So those are some things that we will predicate and stop against. We can also do consents to get that, but typically what you're going to see there is images that are not approved.
So recognition is already pre-trained.
Correct.
Images added will give us a classifier whether it's unsafe or not.
Correct. And you can also add other additional elements as well. So the question was, does recognition already have those elements built in? Yes, you can also add and train for additionals. If you're familiar with some of the child protection laws, right? Age 13, age 17, age consent, all that stuff. I'm sure some of those laws vary across the states, but that is a huge one that's baked into this platform. Now, what can you do with recognition? We've kind of already talked about it, but I can identify, I can analyze, I can search, I can turn around and recreate, I can bond together. Several different things there that we can add into the platform. So a quick question to all of you. If I were to put a label on this environment right here, how would you describe this diagram to me? So it's my architecture. What's happening in this architecture? I'm classifying my pictures. What else? I'm storing it. Okay, where am I storing it in this example? In S3. And where am I pulling my data from with regard to S3? And so I'm pulling data from my Elasticsearch, which I'm doing a massive search, but then where's my data crunching source? Ooh, is it Lambda? So Lambda is going to be my serverless environment where I say, everyone stand up, and then everyone does what? Stand up. Okay, everyone sit down and relax, and then we all sit down. So Lambda is our serverless environment where we can push code on the fly and ask me or you to do something specifically. What about a database? Which one of these is a database up there? DynamoDB. So what would you classify DynamoDB's function is in this scenario? Yeah, I heard a couple of them. So I could be taking my NoSQL environment and doing something and building a schema. I could also be doing what? I heard it over here somewhere. I could be archiving. I could just be storing the data somewhere so that when I have a massive amount of data, could be having terabits of data, gigabytes of data, whatever the case, I can use Elasticsearch to go back and do what with that data? I can query it, right? Yeah, so I can take that data and I can restructure it. So lots of opportunity here with regard to recognition, and this is but one service that we offer. Now, what happens if, I'll turn to Piyush here in a moment. What happens if I'm on a cruise ship? what could we do with recognition there? Piyush, you got any thoughts? And you might have to stand up because I just put you on the spot.
Right, so any ideas before I answer it? In cruise ship, how can we use recognition?
Have you ever been on a cruise? Okay, all right.
How or why you put the
Yeah, why? How it can help? Right. Right. So kind of, identifying people who should not be going to certain places on the ship, right, if they're going there. Right.
I was thinking more along the lines of, okay, where is everybody in my party? Like, when I was on a cruise with my teenage son, he would disappear, and I'm like, okay, where the heck is he gone?
Very good. You're right. So, identifying the people you are with, right, where they are.
recognizing any threats out there, potential threats, maybe security threats,
That's right. Yeah, that goes back to the unsafe image recognition, right? If somebody is, unauthorized passenger, that's something you can do when they're onboarding, right? So you can do image recognition to identify a right person is onboarding the ship or not.
Oh, man, that one hurt. oh, that hurt. Piyush?
Very, very good question. So we are actually working with some of the cruise lines with this kind of challenges, right? So yes, we have recently launched, which is again like Forecast, which is another service announced in reInvent 2018, Outpost, which
Oh.
basically puts AWS on, allows you to put AWS on ship
Interesting.
or
Outpost.
in any traditional environment.
Okay. Had you all heard Outpost before? Okay, so that's a reInvent 2018. If you're not familiar with reInvent, that's our annual conference, November every year. So we released a service called Outpost. The ability to take all of the massive compute power of your machines, put it in a small little box, and then have AWS services be extended beyond our data centers so that you can take advantage. Ma'am, you were going to, you had a comment, theory, thought, design? Okay. Ooh. Yeah.
Right.
Yeah.
That's a very good use case as well, right? To identify if you're not bringing like big bottle of alcohol, which is not allowed. You better purchase it on the cruise.
Yeah.
This new service, how is that different from green grass?
Ooh. Oh. You got to
Right.
repeat that so everybody heard you. How-
Yeah. So the question is, how is Outpost different than green grass, which was already available? Right. Right. You want to answer that?
Sure. So imagine if you're not familiar with green grass, say this is my device. It could be my Raspberry Pi. It could be a bigger server. But I'm running my software, my code on the edge of the AWS environment. I'm extending that maybe to your home, to your data center, maybe back into our cloud on a specific device. So while I can take and run a measure of code on a small little device, and I can push it down in Python, if I want to do Java, I can do C, whatever you want, that is just the only thing we can do. I can't run my other 125, 30-plus services. Yeah, so Outpost is designed to be able to take everything that you have in our world, suck it off of our platform and our fleet, and then run it in this box. Ooh. So is it connected? What do you think? Yeah. So what if I were to do data syncs? Does it have to be connected? Yes. So it needs to be connected. Now the other question is, can it operate in a disconnected mode? Yes. Yes, sir.
How do you see this compared to other vendors like maybe Cisco or whoever they are on the network?
Yeah. I'm glad you asked. So Piyush and I, we work in the cruise industry as well. And one of the big projects we were trying to figure out for the entire industry is, and I'm going to let you take over here in about a second, what can we do in a disconnected mode, right? As mentioned, you don't have connectivity. There's not all these fiber optic cables running in the ocean, so we have to rely on satellites. Satellites run K-band, C-band, CU-band, quite expensive. So how can we take something, put it on a ship, make it run, and then communicate with AWS? Well, right now, we've had something called Snowball Edge. So if you haven't seen that, Snowball Edge is ability to take storage, but then now we can add those compute functions Bill talked about, use it on the fly, but then Outpost is our derivative to scale out. So now, Piyush, what if we were to take a cruise line and try to give us an example on how that would be possible? Is it?
Using Snowball Edge?
Yeah, using Snowball Edge.
Right. So how many of you have watched video of Snowball Edge on YouTube? I would recommend go and watch it. I mean, it's a very sturdy device, right? You can actually, put it in, what is it, temperature variation?
Yeah, pretty hot.
You can go from minus 30s to
Yeah.
pretty hot, right? You
Yeah,
can,
plus 140.
Put in deep ice, it would still work, right? And you can have it in hot conditions as well. So it's a very sturdy device, perfectly suited for edge computing, right? Where, by edge computing, you start doing computing on the ship, right, or in the areas which are remote places, right, near to where your end users are. So you don't necessarily need to connect all the time, right? So you connect to those devices that does the computing for you on the edge. And with cruise ship example, let's say for example, you go to cruise and they take your pictures, right, your videos and stuff, right? You don't necessarily need to send all those pictures through the network to cloud or to your data center, right? You can do the computing on the edge using Snowball Edge devices, kind of, edge computing. You can process those pictures there, and your guests can purchase the picture on the ship without having any network connection to outside world. And then if the guests wants those pictures to be accessible once they get off board the ship, those are the pictures you use the network connectivity to upload. So that's one use case, right?
So how can I tie this back to Amazon Rekognition? Let me give you a use case. I've got tons of photos, pictures. All of you walk on a vessel, and I get a snap of all of you, and you want to purchase those photos. Well, I could use video recognition. I could use some other recognition on the ship through closed circuit TV and then map that back to this. I can take a picture of all of you at dinner and give you a video collage. Tons of opportunity here. But the thing we need to make sure is we're connected. So we have several ways that we can do that. Outpost is still in development, and that'll be available for use in the year. But more importantly, Snowball Edge would be what we would use today to do such. So using the video from your cams, using it from closed circuit TV, using it from other means, we have Deep Lens that can do the same thing. All of that data can be used in various settings. You'll have some of the branches of the government that are already using that, all the way into the civilian world where Piyush and I get a chance to deal.
Right.
Questions?
And I think somebody asked, how does it differ as compared to other providers, right?
Yes, so I'll comment on that now. If you look at, I came from Cisco, you have UCS, right, Unified Computing System, B Series, C Series, all that stuff. You have HP, right, they have their stack. You have Microsoft with their Azure stack, right, we all are friends here. You have all these different players out there. They have their all-in-one, and this is going to be our all-in-one approach. Yes?
My question is a little different. Let's say on cruise lines we have Wi-Fi everywhere, right?
Right.
Using Cisco's wireless LAN controller.
Correct.
On UCS.
Yep.
Add more computing there. How will you see that type of setup versus this one?
Yeah, so Microsoft has their Azure stack, right? The ability to partner with and then put in a bunch of boxes, do all the good stuff. Cisco has their stuff. They use their wireless LAN controller, put it all together with their UCS, et cetera. Our strategy is definitely going to be either using Snowball Edge or using Outpost, where we take, again, a bunch of compute power, smash it down into something a lot smaller, and then more importantly, allow you to use our environment. The elasticity of the cloud is what you want pushed down to that device, not necessarily the other, because then that takes us back to the traditional data center. Does that make sense? Perfect. Hang on one second. Yes, sir.
Are these edge-based computing devices, they GPU-based or TensorFlow?
Ooh, So are these edge devices GPU-based? What does the audience think? Yeah, they are. Yeah, so it's a machine, one, right? So we definitely need to make sure that we've got the computing power. Otherwise, we're just going to smash the CPU. But yeah, GPUs are baked in there. We've got Deep Lens, if you haven't seen it. Basically, it's our machine learning device that has camera functionality built into it. We have Deep Racer now that just came out as well that has the ability to do some fancy stuff as well. And then you have other camera manufacturers that allow you to do the same thing. And then now you just use our tech to make it all work. So just a lot of options, a lot. And my manufacturer that I work with now, we have a whole manufacturing line that builds product for Amazon. It's interesting because we've got these expensive cameras that are just watching the manufacturing line looking for defects. We're capturing the moment. We're doing the essence. We're also going back and getting the epics, which are classifying how things are working, not working, where we're seeing errors. And then we have GPUs attached to them as well. So just lots of different examples you could use. In this example here behind us, you see that there's pictures just taking a look at the community and pulling that same sensor data out and then sucking it back in. Quick question, because this is my first time working with Amazon. What are those little things around everybody's faces? What do you think? Trackers. Yep. What else?
Gives you the dimensions of whether it's in line in terms of data.
Okay. Yep. So dimension identifiers. Those are what we call bounding boxes. Yep. So that way I can keep close proximity. I can track. I can target. That way I can classify if I see a male, if I see a female, if I see an animal, what type of animal it is. All those are things that we're tracking in those images. So it's just awesome technology that we get a chance to work with there. Just kind of transitioning here. Now, if you look at how all this data gets bound up together, Lambda, we mentioned, right, is the ability to take some code that you all write as experts, developers, builders, and then wrap that code into something, right? So if I'm doing a .py, tell me how to functionally create and push this over to this script. I want to know how I import this over here and do X, Y, and Z. So lots of different mechanisms and things that are important there. Now, what about speech? If you think of the tools that we have for speech translation, what do you think Transcribe is? In your own words. So you have to read really fast and then transcribe that into your thoughts. Audio to text, okay. Speech to text, okay. All right. What's one other element we need to add to that? We could add that. We could add semantics, we could add language. Do you want it to be done manually? Automatic. So with our Transcribe service, again, reInvent launch, we want to provide you with the unique ability to take something, and this is going to be part of your lab coming up next, so you'll have to memorize this. But I want to take something that's automatic, automated, take speech, recognize what I'm doing, irregardless of the language or the technique or the synthesized data that I'm using, and then make some adjustments. A couple of seats up front here, if you desire. Now, with regard to, yes, sir. So I was hoping somebody asked that. What is Mechanical Turk? Anybody know? Go for it. Go for it.
It's just a service where they take your business request and pass it on to somebody that can deal with in their network. It's like a big tent
Yeah.
with a whole bunch of businesses under it.
Right.
And whatever you need, they got it.
Yeah. People processing power all wrapped under one roof and then processing it together. So to your question and answer there, that is exactly what we do in the Turk environment, in addition to some of the other stuff that you see ported over here. So again, right, the objective is that you are not locked into one service, but more importantly, you have the unique ability to try out some of everything. With Transcribe, you'll see that there are several different flavors that we can use, right? I can support both through telephony. I can support through my computer, my CTI, computer telephony integration. I can also take and do something off of a machine that has been and doing all these things, and then I could have a dictionary that does the same format there. So ideally, you've got a lot of exposure and opportunities to take and make this better. So here's a quick summary of what you get with Transcribe. Once I go and look at the platform, once I take the amount of data, once I have summarized how all this data comes together, then I can put it into the media world, and then I could use it successfully. In Atlanta, there's a pretty big media company that most of you may be familiar with. There's also a large media company in Orlando, Florida. I'm sure none of you know who that is. But ideally, right, they have billions and billions of artifacts that have to be crunched, processed, and transcribed for us to experience our moments on the screen. And this is but one way to do so. Now, you'll notice that with Transcribe here, this is a much different technique. So could someone walk me through this design? Because again, this is my first time here at Amazon today. What's happening? Well, let me take a step back. What's my outcome that I'm looking for? I want to be able to capture my moments, my text, and do something with it as a derivative. Perfect. Now, what is this design right here actually doing?
Monitoring your data transcribe, QuickSight is a monitoring tool.
Okay, all right. So you're going to answer what QuickSight is in a moment. Let's start from left to right. Audio. I take all of my audio. Hi, Mike. How are you today? Fine, thanks. Good. How are you today, Karen? Great. So I capture some text from these two individuals. What happens next? Oh, okay. What was the first name? Kiana. So Kiana, what am I doing after I capture that text? I'm storing it in S3. Okay, all right. Now I've got all that data in S3, and I'm coming over here to Stan. What do I do next? I process it. Where am I processing it? And I'm using what with Lambda? Oh, thank you. Perfect. Now, so I've got my video, I have my data, I have my audio. I'm marrying that together. Now, what's happening next? Ooh, I can't comprehend it. We haven't talked about comprehend. So what is comprehend?
What do those words mean?
Okay, all right. Yes, and Marty, thank you, Marty. And Carol, what were you saying? Karen, sorry. So now I'm trying to really understand what am I doing, all right? So now I've translated, I've transcribed it, I'm trying to understand it so I can put it together. Now we get to something called Athena? Oh, Athena. Oh, Athena. What is Athena? Ooh, we're getting close. So I'm querying something. What am I querying, though? I'm querying some type of language, some type of character recognition, and what else? The semantics from where, Marty?
Probably have a database that says this word next to this word has this sort of meaning.
Yeah, and where did I get all that data from up until this point?
Dictionary.
Yeah, my dictionary, which comes from Transcribe and Comprehend, and now that brings me to, was it Raj? Yeah, Rajat. Where are we now? What's the last piece to bring all this together so we can see it? Now we have QuickSight. So visualization and QuickSight, our BI tool, our nice little dashboard to glue this all together so that you can actually see a report. I can click on the bottom, like on our, if you have an iPhone, when you go to click a message and you record it and it's doing a little squiggly audio, and then at the bottom it pastes that. The same principle is being applied here, but now we have the ability to look at it through a UI. And that UI we offer, equivalent to like a Tableau, is QuickSight. So we're going to sweep the room 1, 2, 3 here in a second. Yes? Yeah, so the storage layer is S3, simple storage service, right? S3. Comprehend is going to suck all of that data from S3. Correct. Yeah, so what's happening, you have my transcribe, the ability to take my what to what? Right, my voice to text. And then I have my comprehend to do what? Make sense of it, right? And then the last piece you just touched on, which is what? But I need to query it. So Athena is a query engine so that I can take all my SQL, my schemas, and go out and pull all that data together. So if I've got .mp3, mp4, and MPR, all those stuff, I can use Athena to go back and search through those and get specific text to go out and find what I need. So, yes, I'm glad you said that. So what was the first name again, sir? Sri. So Sri was saying from the diagram, it's not really clear what's actually happening. So if you look at this holistically, everything that we do here at Amazon uses S3. S3 is our very large data lake where all data is stored. We use it to go out and do a repo. We come back and use it as a repository to go out and pull all of our services from. So behind the scenes, everything inside of this environment is going to collapse back to S3 from a data source. Now, Athena, on the other hand, has these specific hooks inside of there so that I can realize where that data, where that query needs to come from. And with regard to Athena, if you haven't seen, we can do the S3 to Athena query selection on the fly. So that was a recent addition in the last year. Before, we would have needed to see a line to come over like this. Now we don't have to because it's sucked through the services together. It's transparent. Correct. Correct. Yep. No. It's not meant to highlight Athena. It's meant to highlight this piece right here. Yeah, because Athena, again, right, there's a whole specific thing around it, but Transcribe has the ability to what I'll say, has multiple legs that it can hook into multiple services at any given time, which is why you just saw a cut through here. Perfect. Yes, sir. Right.
So how is Transcribe going to fix that if it's, or does it fix it after, because it sounds like Transcribe does a speech-to-text conversion, but then it's the context of that statement.
If it's correct.
To supply the
Yep.
actual correct word.
Correct. That's where comprehend will come in and clean that up. So perfect example, how many different ways can I spell bear? Bear? I don't know, you tell me. Right. I need to go lay bear fault. I just saw a bear. So in the context of your question, right, when I'm going through and looking at the phrase in the sentence, we use Transcribe, we look through a rules engine, and we make sense of how the sentence structure is, and then we can comprehend that by going through and cleaning up with synthetic text. So we will need to rely on more than one service to do that. Because we've got Translate, we've got Transcribe, we have Comprehend. If I'm using Translate, then I need to flip that to another language. So that's a third element where I can go out and address that as well. But primarily to tackle what you just highlighted there with those phrases, those words, and those synonyms of different things, we use Transcribe working with Comprehend. Yes? Oh, sorry.
The output from Comprehend be fed back to Transcribe, or is it just have another copy of the data?
Gotcha. So after I've cleansed my data, will the data remain intact, specifically with the outcome? Or do I go back and repurpose it, retool it so I can make use of it? That's going to be dependent on how you want that data. So everything in the cloud world costs a few cents, right, per gigabyte. So if I want to take this environment and specifically clean it up here, comprehend it over here so I fully understand it, and then process it down here, I could have revision 1, revision 2, revision 3. I could have a stage draft finalized. I can do several different iterations on it. I can go back and cleanse it multiple times and make sure the data is succinct and is accurate. And then finally, I can add the human element if I really need. So there's a couple different tools that you could use, but in those two services, we have the ability to capture that. And with data, it gets what over time? Smarter. So the more we feed the model, the more we train it, the more we starve the actual rules engine of data so that we can go out and correct, self-correct, and add definitions to the database, then it'll get stronger and smarter. Yeah. Yes.
Is this the same system used in the closed caption for CNN and Disney?
Ooh. No comment. Yeah, but I will say that if you were comparing named industries, I would say that
You said Atlanta and Orlando.
there's a couple of different agencies and companies and places, but I will tell you that things like this are definitely used in the state of Florida and the state of Georgia.
The reason I asked that is from the point of view of the real time.
Yes.
Because if you are doing closed caption, it has to synchronize with reference to the video.
Correct.
Is there any delay in the transmission that they have to make in order to accommodate this processing?
So I've actually been on a studio, and I've seen this real time, and what I will tell you is a lot of the manufactured delay that's there is cleansed and cleaned up with all the different editing that's taking place. Now, with regard to real-time streaming, yes, there is a slight delay, but then that's when your codecs and all your audio clips will catch that as well, which is why you have your 264 and all the other things in that. But yes, it will capture that near real time. And when I classify near real time, I'm talking down to the millisecond, nanosecond, not actually clip for clip. Yep. If you haven't seen, on all TV, on all audio, there is always going to be a delay. So I've been at a certain place on an NBA setting, and there's about a 3 or 4 second clip or gap between when data is actually streamed and then more importantly when it's pasted to your TV or to your tablet, whatever you're streaming from. But that's all by design so that they can capture, they can clip, they can watch out for words that shouldn't be used on TV, and then they can basically paste it out as needed. That's a little trick in the media world that I don't think most people are introduced to. Yeah.
Does this work only with English or
No, there's multiple languages that's baked in.
can it work with a completely unknown language, say Martian?
I'm going to say no. Let me clarify. Can it work with Martian? I will tell you that it can be trained to do that if all of our software developer engineers put that ability in there, but out of the box, no, it won't work. Yeah, we've got a finite list of languages in there. I don't remember the exact number. Yep. Yep. Dot.
Somebody from Boston sounds a lot different from somebody from, say, Iowa.
It can pick up on that. Yes. Yes. Go ahead.
So can it do that with data streaming from social media?
So organically, no. But through programmatic means and pulling RSS feeds and getting access through Cognito clips, yes. So I just told you that basically we've got to take like 4 or 5 different services, cobble them together, throw it into a data pool, and then go out and then extract. That's how we'd have to do that. To build or for it to actually show you the transaction? Oh, seconds. Yeah, to build, it's going to take a while. The last time I was out here, I actually met a nice young lady who was actually working on just that thing and had a pretty cool tool that she built doing exactly that, and then capturing it with AWS Mobile Hub and spitting it out to a phone, and then, yeah, it was pretty neat. Yeah. I don't have her secret sauce, but I saw all the services she used, so that I can share. Perfect. Yes, sir.
So I was wondering, like, if all Amazon Transcribe does is to convert the audio file into the text file, can we not put that in the part of Amazon completely? Because, I mean, there
That's-
is requirement
Yeah, that's why they work so well together. So the question is, can I not bake all of that into one service at the same time? The way our company likes to function and operate, we want to make sure that when we build something, it's because of a need that we saw and developed and we had a struggle. And so we created it, and then, we created it, and then we brought it to life. So you'll find out that we want everything to be glued together nicely, but not have a single dependency on another service. So if that were a request, we would need to take from our team over here, put it into our feature request tool, and put that in. But typically, they want to keep those succinct and separate.
I guess generically, the transcribe was developed first, and after that,
Correct. Yeah. Yeah, so we did transcribe first, and if you follow the internet, and I think we've all used another well-known translator because we're all fluent in like 20 languages, right? This is our way to kind of do the same thing, but in the AWS world. Yes?
How is learning happening in concert? Is it like constant human intervention? Like when the news forecast or whatever newscasters are talking, the closed captions are not always accurate.
All right.
So how is that happening while live streaming?
Yeah, so what's really nice, how's the learning and the adaptive learning taking place in these services? I would tell you, if we are layering in an ML component, then it's being learned and adapted and grown by data. If we're not doing that on the fly, then it's being fed by alternative video, audio clips, and then we cleanse that over time. But specifically, does it do it organically? No. It has to learn over time. And then what's nice is that your specific AWS account is different than mine. So as you feed it data to your system, your account, your environment, then specifically your environment will get smarter. And then in turn, as we are watching and sweeping and scrubbing and adding more dictionary lookups, then our system gets smarter. And now it's just a matter of how we cobble that together to make it work. So it's a team effort here. One thing is pretty important. We are not looking at your data. So whatever you're using on our platform, as long as you're abiding by the laws and we don't have any contractual, obligatory, or requests, subpoenas, all that stuff, we're not looking at your data. That's the whole shared responsibility model. So as you build your system, then you are feeding it all the intelligence over time. We are just complying with whatever is out there in the Merriam-Webster's dictionaries, other sources, and then we make that all one conclusive footprint in the service.
So is there another ML service in there?
Underneath the covers, yes, but you never see it. Yeah, it's the same way with Alexa. Alexa's got a couple billion lines of different utterances and clips inside of there to make it work. This is the same similar deployment. And I think we've got a few minutes left, and we're pretty much at the end. Quick question. What do you think we should use with regard to this service? I heard robocop. Oh, calling, robocalling, yes. Robocalling is an irritation, yes.
Well, for instance, I had an issue with AT&T customer service on chat where it was talking to me and listening to what I was saying, but it wasn't comprehending.
Yep.
And the responses certainly weren't making sense.
Sure.
But it almost sounded like a human.
Yep.
It wouldn't pass the Turing test, but
Gotcha.
it was close enough.
Perfect.
Because I was like, they're saying, well, I can help you with that problem. I go,
Yep.
You don't understand the problem.
Mhm.
Well, I can help you with that problem.
Yeah. I love it. Great analogy. Yes. Yeah, so we've all been robocalled. That was a perfect example, calling AT&T. Poly is another way for us to take that synthesized text, speech, and turn it into a human voice or human-like voice. Yep. Correct. Yes. Have you noticed, to that point, that all these robocall somethings are getting smarter? Yeah. So that's a derivative of things like this, right? Where they're building, there's tons of different software stacks out there that allow you to do these functional tests with voices. But right now, we basically will take that speech like text that speech-like audio, snap them together, and then we'll put them across 25 different unique languages, and then we will allow you to build a service based out of it. So if you want to create your own robocall instance, you could use Poly and other services to do so. And you kind of get the point, right? You've got all these different options. But for the vast majority of those here in the States, we want to make sure we turn it into something profitable. Press 1 to get to a customer service rep. Press 2 if you need to order a new credit card. Press 3 if you need to do this. So ideally, that's what you're getting. When you talk to, I prefer to fly on Delta Airlines, same thing, right? I go through that speech recognition pattern analysis, do the same thing here. Yes?
I would be able to use this for translation services.
You sure could.
Customer service call.
Yep. Yep. So can I use this on translation services? Absolutely. You'll notice that all three of these we mentioned, right? Transcribe, translate. What was the third one? Comprehend, Poly, and then also there's one more called Lex. All 5 of them are just an awesome story to build out. So you're familiar with Alexa. Lex is what? Yeah, it's the compiler that's built into it. Yeah. So I could take all of those and snap them together and have a great story to build out a nice framework, a customer service agent, some pooled data amount or source to be able to build out a platform or an architecture. And I'm sure here in San Fran, a great way to tie all that together.
That's a great point. I was just talking with sales rep.
Yep.
And so to design a bot that fields questions from the end user on anything, whatever your sales, your product or service might be,
Yes.
they have all these tools, right? But Amazon has tools, Alexa's like the
Right.
core of the product. Do you have any actual use cases that we can look at online?
For Lex? Oh, yeah, there's a ton of them out there. In GitHub, there's some great examples. If you go to Lex, when you log in, you'll see these little 10-minute tutorials on how to create something. I created something about a year ago for my little niece. Just to, kick around, 5, 6-year-old, just understanding, asking questions, and created a nice little web interface. So it just could ask her questions, and I just put in there simple math. So there's a ton of use cases that you can all think of. What's really nice about Amazon, right, is that all of you have different levels of creativity. So depending on how well you're allowed to use that without breaching your IP, your intellectual property from your company, great. If you want to start out, do your venture capital, create your own business, you can do that as well. So it's pretty nice that you can come up with all kind of ideas and use it with AWS. Just a couple more things here, and then we're going to wrap up here so you can anxiously get to the labs and take a break and move on. So how many of you have built a chatbot before? Okay, great. What is a chatbot? Because this goes right back to Lex again. Let me give you an example. So if you're familiar with ServiceNow, what is ServiceNow? Help desk, right? So my computer crashes. Obviously, I can't open a trouble ticket because what happened? My computer's crashed. But I may have my phone, and if I can get to my own internal URL, maybe I can go through a chat bot and say I need help. And then I can turn around and give you all these intents. I can create utterances, and then I can do my styles and say, well, what do you need help with? I need $1 million. Well, obviously, that utterance is not going to be in there, right? So what would happen? Yeah. So what may I really help you with? Oh, well, my computer's down. Okay, now I've got search words inside of there. And again, this is all through Lex, tied into a chatbot, whether you use Slack or any other means, that's up to you. And then now I'm saying, okay, if I see computer down, computer outage, computer problem, computer frozen, now I can kick off all these other words over here to make sure that everything works. So I personally love chatbots because they're simple to do, they're very authentic, and they can be tied together through security and through APIs to make sure your environment really sticks together. So here's another good example, and this is kind of mapping this out, but This is really using Lex and also having the environment with chatbots created together. So almost every example that you'll see on the service page has a nice little tutorial. It has a GitHub repository where you can go out and copy, and then again, just start re-engineering with your own ideas and make sure the environment sticks. And that's kind of what this next slide is about Lex, right? Being able to take my voice, being able to take my text, tie those two together, and then have a great story. Questions? We're pretty much right at the end here. All right, I'll just show you this since we got 5 minutes left, but I'm only going to take 1 minute. Take a look here at this example. And you were asking, what was the name, sir? Yes. Ethan, perfect. All right. Thank you, Ethan. 5 quick examples. You know it's a really cool one? So we built a chatbot, our Eastern team here from Atlanta and Florida, about 2 years ago around chatbots and being able to take IoT devices. And we would actually tell Lex, turn on light. And Lex, make light blue. Well, I don't want to make the light blue. Can I make it green? So we put in all these little weird things. We made something really awesome. So I would recommend that if all of you can ask your employee to fly to Atlanta, come to the Atlanta AWS office. We have, and I'm going to let my friend here mention it, the beer machine.
Oh, yeah.
Yeah, you want to grab the mic and tell us about it real quick? And we got like 5 minutes, so maybe you can take a minute or 2.
Sure. All right. So we have started a simple beer service. So that's nothing but you get to grab a beer, and the way you do it is you tell Alexa or use the Alexa skill, and you place a glass of under the SBS, we call it SBS, and say you need a pint, and you get it, and you get an ounce. So that's the service that we built using our own technologies. It's still there in our office in Atlanta that we use. However, we recently found out the beer is not being replaced so often, so it's stale and sucks. But the service works with our own AWS services.
Awesome. So did you hear that? Simple beer service. That's a new service we created. And but it's not publicly available on Amazon.com. But what's really cool is that, I mean, we're using IoT. We're using some of our own back-end things. There's actually a little beer station. You pop a clutch, right? You hit the bottle. You actually ask it. And then you have your cup. And you get a pour. It's pretty amazing. Now, this is after hours, of course. But you get again, right, we're trying to give you ideas to use and make sure that you can creatively use our platform because every person here in the room is a builder. Questions? And then we're going to wrap
I
up.
was just going to comment that the
Yep.
previous loft actually had SBS there.
There we go.
You asked for a beer at
Yep.
the loft, when they had late night events.
So you've seen it.
Events, you
Yes.
just walk up and ask for a beer, and the SBS service would pour you a beer.
There's a real life experience and example right there. Perfect. Thank you for sharing that, Marty. All right, so we are 3 minutes early. We're going to wrap. Just a recap. Restrooms out on the right. 222 is the code. You got the Wi-Fi on the board there if you need it. This lab is going to be pretty interesting. So while we're taking, what is it, a 5-minute or a 10-minute? We're going to take a little break, and I think food's out front. So I'm going to get set up, and then as everybody gets back seated, then we're going to go right into the workshop, which is where all of you need to use your laptops now. Excellent.